Hello and welcome back to the channel. Today I'm going to talk about an important topic, data types in programming. Generally when programming, information or data values is assigned, stored, and manipulated using data types. Therefore, understanding the concept of various data types and their use case is very important when learning programming. In this video, we will talk about different data types built in by default in Python and how to set and get the data types using variables. We will also briefly talk about mutability and constants in Python. I will show some of the examples use case on when and how to use these data types along the way. A couple of notes. This video will have a lot to digest. So while you work alongside me, please feel free to pause and play the video as many times as you need. Also, making contents like this video takes a good amount of time and effort. So if you like these contents, please subscribe, like, share, and add your comments below to show your support. So let's learn about data types in Python. There are various data types in Python, and different types can do different things. Some of the important types are shown in this graphics. This is by no means a full list of data types available in Python, but we are going to cover some of the most useful ones for beginners. Before I dive into the data types or assigning data types to a variable, I want to clarify two things. First, everything is an object in Python programming. Therefore, data types are actually classes, and variables are instances or objects of these classes. We will soon learn that every object has three different attributes: identity, type, and value. We will talk about classes and objects later in a separate video. Second concept I want to establish is mutable and immutable objects in Python. Basically, what mutable means is the value of element of the object can be altered. On the other hand, immutable doesn't allow any change in the object once it has been created. Although you can't modify an item within an immutable object, you can assign a new value to a variable that represents the object by redefining the entire variable. In this graphics, what you see is there are different data types such as numerical. Under numerical, we have integer, decimal, or complex numbers. Um, um, there are textual data type known as a string. There are collections. Under collections, we have list, tuple, dictionary, set, frozen set, Boolean, binary, under which there can be bytes, byte array, or memory view. And there's on the yellow, on the far right side, you can see a special data type called none. As you can see, most of this data types in this graphics are uh, either have a red lock or green unlock icon on the right. What they mean is the red one indicate they are immutable objects or data types, and the green one basically means they are mutable data types. Rather than explaining the theoretical concept of mutable and immutable in Python, working with simple code will help better explain the concept. You will see what I mean by object being mutable or immutable later in this video with example codes. If we take a moment to look at this chart, you could easily say that we could put text string under collection type and also Boolean under numerical type. But the order or hierarchy of this chart doesn't really matter. What matters is our understanding of the concept of different types and their importance, basically when to use what type of data types as best suitable. So let's head over to PyCharm and dive deep into different data types. As you can see in my screen, I have two print statements here. Uh, as you saw in our in the last video, what we are doing is we're just printing out the output in a print statement, whether it be a string like a text string like a namaste in the first statement, or it could be a numerical value like a print 10 on the second statement. But here in this print statement, we are just providing the value so that it outputs on the terminal, or the result of the code. But we are not manipulating data, or we're not saving raw data into memory in the computer and then later extracting the value to do other stuff in our code. We can easily do that. One way to do it is just assign it using operator like x equals to 0. And when we run this, we get um, we don't get any errors here. So let me explain what is happening when we write an assignment statement like this. First thing you notice is that Python has no command for declaring a variable. So what we did here is we declared x to be a variable, and we use the equal to operator to assign value 0 to x. So here in Python, we don't have to explicitly define a variable type. A variable is created the moment you first assign a value to it. Like I said earlier, in this example, we are using assignment operator equals sign here to assign the value 0 to the variable x. The value to the right is the literal or raw data provided. Literals are the raw data that are assigned to variables or constants while programming. The variable x to the left is assigned the value 0 with this statement. A variable is a named location used to store data in the memory. Think of it as a container that holds or stores raw data. To later use the stored data, we simply call the variable name rather than the memory location where it is stored. We can do that by simply saying print x. And then now when we run this, we get 0 as output because x was earlier assigned as 0. Now one might be interested in knowing what is the data type of this variable. We can easily do that with something like um, type x, and then when we run this, oops, I forgot the print so that it prints out. So print type x, and let's try again. Okay, here. So earlier, from the earlier print statement, we had printed x value, which is 0, and then the new print type x, it actually types what is the data type of this variable x. In this case, it's an integer because we are assigning 0 to it. In the last example here, we didn't explicitly assign variable type when we use the variable x, when we assign x equals to 0. But if you want to explicitly specify data types of a variable, we can do that with this with the casting. So what casting does is we explicitly define, say, let's say we want a variable named count, and we say float, let's say 9 in this example. Then we are explicitly, although 9 would usually be integer, because we are assigning it to be a float, we are now explicitly saying count to be a float type. So when we run this, we still get the same output because we are not creating any new output. Now, if we usually say count 1 equals 9, and then if we want to print type of count 1, and then also print type of count. So when we run this, Um, when we run this, what we get is, so first we assign count equals to float 9, and then we assign count 1 equals to 9. In this case, count 1 is an integer because we are not explicitly defining anything. And since 9 is an integer rather than a floating value, count 1 would be a floating type. So when we say print type count 1, it actually output, it's showing a correct output of floating type. Similarly, um, count 1 count 1 is 9 integer, and then when we do print type count 1, it's showing us um, that it is an integer type. Another thing I want to show you is how do we get other attributes of this different variable types or objects. Like I said earlier, um, every object has 3 attributes: identity, types, and values. So we already looked at the value and the type. Let's look at the ID of this variables. To get an identity of a variable, we simply say print ID x, and when we run this, it's going to give us the ID output. If we instead are interested in outputting a hexadecimal input or hexadecimal address output, all we do is hex ID, and then instead of decimal identification, we get a hexadecimal identification. Hexadecimals basically contains digits from 0 to 9 and alphabets from A to F. So far at this point, we have created a few variables like x equals 0, count, or count 1. But I want to talk also about the naming convention of when we name variables in Python. When we give a name to any variable in Python, the name can only contain letters, numbers, and underscores. When naming variables, you may be tempted to choose simple single letter lowercase names like x in this case. But it is better to use descriptive names such as count or count1 to make it clear what the object represents. It will also be uh, to be noted that spaces and special characters are not allowed. So if we say count 1 equals 9, it would usually give us error. Or count dollar or %1 would also give us error. If we are instead to use separate words, we can use underscore 1 to say count 1. This improves readability of the code, or when we assign variable, it's easy to read that this is count 1 versus when we had previously just said count 1. So it's better to separate words with underscore to improve readability. Another example would be, let's say my underscore variable equals 90. And when we run this, we don't get any errors. Names can also use combination of letters in lowercase or uppercase. For example, in this case, let's say my variable, and then we assign 909 to this, which is still fine. The only underscore we are getting is a typo, which is a low warning, and it would still run fine. But we have to note that names cannot begin with a number or digit. So if we are to say 9 underscore y underscore variable equals 99, that would raise a flag for error. If we run this, we would get syntax error. We also have to note that variables are case sensitive. So so let's bring in another variable. I want to delete all of these code, and let's say circle diameter equals to 0. Nothing wrong with that. But then if we say another circle diameter with lowercase d equals to 0, and then another circle diameter with lowercase c and d equals to 0, now we are assigning three different variables. All are saying circle diameters, and all of them have equal value of 0. But since variables are case sensitive, all of these are not the same variable. When we run this, we don't get any error. And if we were to see types or the ID of each of these, we would end up getting different ID values. Another thing to note when writing name convention under name convention is where we should not use known keywords or built-in function names to assign as variable names. So let's say, for example, type, as we saw earlier, is a known keyword or built-in function. And if we are to say type equals 9 or 0, and we were to run this, it would still run, but it would still raise a low flag saying it shadows a built-in name type, and it creates a confusion to programmer later on when the code grows. Next thing I want to talk about is changing the value of a variable. Let's say, for example, we are working with a number which has a dynamically changing value. So, for example, as earlier, we started with x equals to 0, and then later, at some point, the code in the code or when the program runs, x value, let's say, updates to x equals to 99. So in this case, when we do print x here, and then like in earlier case, when we try to find type of x, and then also print the ID of this x, and then let's say we run the same bit of code after we change the value, you might be interested to see what we get here. So at first we had x equals to 0, and it detects that it's an underclass integer, and the value or the ID is this. Now when we change to x equals to 99 and print x, it correctly prints out 99. The class type is still integer, but the ID of the variable has changed. And that is because integer, as we saw earlier in the graphic chart, is immutable object. And since we are updating the value here, it's not actually um, updating the item inside the variable, but it's actually creating another memory location for that value, and then the variable is just um, referencing that value in the new location. As we saw, we can assign integer value of 0 as well as a positive number. We can also assign integer value of a negative number, and it would still run just fine. As you saw here, negative 99 is still an integer class, but with a new um, address ID, as we saw earlier. In Python, when we set large numbers, we can usually say something like this. Um, every letter separated by underscore, and Python, when we run this code, Python usually just ignores the underscores, and this is the same as just writing this number without the underscore, and we can still do all the same stuff that we did with this new variable z, and when we run this code, we still get integer class. And when it outputs without underscore, and it still has a variable. The variable still has a ID assigned to it as a reference value. We can also set multiple integer values to multiple variables at the same time. So let's say a, b equals 9 and 8 respectively. And then we can do print a as well as type of a, and then we'll do similar thing for b, print b and type b. When we run this code, we still get for a value is assigned 9 and it's still integer, and for b value is assigned 8, which is also an integer. Another alternate way is we can assign same value to multiple variables. So let's say a equals to b equals to 9, and in this case when we run this, since we are saying both a and b are 9, that's the correct output we get. Both a and 9 are integer and both are assigned value of 9. Going going back to the previous example, when we did a comma b equals 9 comma 8 to assign multiple values to multiple variables at the same time, we have to keep in mind that this is not the same as a equals 9 comma 8. This instead is how we assign a tuple, which is another data type, and we will discuss tuple later in this video. So in this case, when we run this, we get an error. Let's comment out this and try again and see what we get. So here a equals 9 comma 8, and when we print a, it's printing 9 comma 8 as a tuple class instead of integer class. Next, I want to talk about floating point numbers. Floating point numbers are values or numerical values with decimals, and decimal can be in any location within the number. So hence the idea of floating point number. So let's say b equals 9.8. And then similar to previous statement, when we do print b, type b, it prints 9.8 under class float. So 9.8 is assigned to variable b, and variable b in this instance would be of floating type variable. A floating point number is accurate up to 15 decimal places. So let's say if somebody gives us a grid line that is accurate more than 15 decimal points, like in this case, um, which is fine, but when we store and later manipulate this, let's say we run this, you see this truncated thing here, it is actually only truncating 15 decimal points and ignoring the rest of the values, but it's still correctly classified under floating number type. Floating numbers can also be exponential numbers. When we assign exponential values, it is default stored as a floating number. And let's say in this example, our ceiling or threshold for maximum value is 2.537 to the power or exponential 5. Uh, when we store this and then later print this, we would get 25370.0, which is a floating point number. Next, I want to talk about swapping the values between two different variables. So for example, if we have two different variables assigned, A is assigned 19 and B is assigned 78.9. In this case, A would be integer class of value 19, and then b would be a floating number of value 78.9. But then later on in the program, if we are to exchange or interchange values between a and b, we can simply say a comma b equals b comma a, and then if we are to print values of a and b again, and let's run this code and see what's happening. So this was the previous value, a equals to 19 and b equals to 78.9. After we interchange values, now a becomes 78.9, and it's now instead of integer, it's now a floating value, and then b becomes 19. Instead of floating value earlier, it now is integer value. Next, I want to talk about complex numbers in Python. We can assign complex number in the form of a plus bj, where a would be a real part, b would be imaginary part, and then the complex part, and then the j is basically a square root of -1. So we can say something like num equals to 4 plus 2j, and then when we say type num, let's comment all this out, and then run this. Actually, just delete it, and let's see. Type num, we gotta print it, print type num, and it should give us class of complex type. We can also use um, a and b variables that were previously assigned to then later use it in creating a complex number. So again, let's say a equals 19, and then b equals 78, similar to in previous example. And then let's say we create a variable called y. We can say, we can use a constructor, complex constructor with a and b to create a complex number. And when we print y, we should get a complex output, 19 plus 78j. Next thing I want to talk about is type conversions. So let's say we have a a variable num equals 9.9, and we know this is type float. So let's run that and see anyways. Again, print type num, and when we run this, it would give us a floating number. Now, let's say we want to convert that num into integer, and we do that by say int constructor, and our input would be num. And when we now print type of num integer, we would get an integer number. But let's say we are also interested in finding the output of num integer. In that case, we just print num integer, and since we started with 9.1 and then converted it into integer, it only takes 9, which is the integer value, when we printed num integer. And when we printed type of num integer, it's giving us integer class. So let's go one step further, and this time I want to convert this integer back to a floating number. So what I have now is num integer now I want back to num-integer back to a float number. And I do that by a float constructor, and the input would be num-integer because that's the integer I wanted to convert to a floating number. When we print, I want to print num-integer float, and then print type of num-integer float, and let's see what happens. Now, what is happening here is I started with 9.9, and then I converted into which was a 9.9 was a floating number. I then converted it into integer value 9, which correctly gave me a class integer. Now what I did was converted it back into a floating value. So this integer was inputted into the float constructor, and I constructed a floating value 9.0 out of that integer, and the type is now again back into float. So this shows we can switch back and forth between different types using type constructors. You can also do this with other type of data types, not just limited to integer floats or complex. But one thing we have to also understand is we're not, um, since these data types or numerical data types are all immutable, we're not changing the items within the type or the data type, but we are assigning new memory address and then assigning a new value to that new memory address every time we are doing type conversions. If we go back to our data type chart, so far we have covered numerical integers, floats, and complex numbers. What I want to go next is the Boolean data types. Boolean basically means true or false values, which basically are either 1 or 0, or existing value or not or empty value basically. So if it has anything other than 0, it would be true. If it has 0, it would be false. So let's clear all this on the screen and say, let's say an example, animal equals true, and then tree equals false. So what we are doing is we're basically here creating a flag saying, hey, this, if we are to describe something with flags, we can say, hey, this is an animal, saying animal is true, and then because it's an animal, the tree flag for this would be a false. For this, I want to go to Python console and show you the output. So let me exit out of this presentation mode and go to console. Here I want to say in this example, I want to say A equals to 9.9, for example. And then if I'm to say bool A, it would give me true because it is anything other than 0. We can do that with a floating value of 0. Let's say, for example, B equals 0.0. Because this is exactly a 0, bool of B would give me a false. Um, in Python, we are basically in any programming language. We use Boolean values or Boolean literals for comparison between two different conditions. We'll see this in more depth in future chapters when we do conditional operations and other operators and use other operators. Next, I want to talk about a special data type called none. So let's switch over to presentation mode. In Python, special literal none is used to signify that a particular field is not created. Python will print none as output when we print the variable with no value assigned to it. As you saw in the previous example, in Python there is no need to explicitly declare data type when assigning values. When programming, you can easily assign empty literals to a value to later work on it. For example, let's say middle name equals none. Nothing wrong with this. When we run this, we don't get any error. When we print this out, let's see what we get. Print middle name. It gives us none. And when we print type of middle name and run this again, we get type class non-type. And then when we add another statement to say, I want to see ID or location where this is, it would give us a location. So we can see the none class has value, identification, and type assigned to it, as we discussed earlier. Now, as a programmer, sometime later, as we go along in our code, we can reassign the value to the middle name um, to, instead of none, we can say, hey, Jack is my middle name. And then when we run this, now, instead of previous none value, now we get Jack value in the middle name. And that would be under new location. So that tells us this none is also immutable object type. So far we have discussed numerical data types, which are integers, decimal, complex, and booleans. Next I want to talk about is another simple data type, text or string data type, and then we can go into collections. String is a sequence of Unicode characters, textual representation of data. We can use single quotes or double quotes to represent strings, just like here. Middle name equals double quote Jack. We could also do this with something like, instead of double quote, we use single quote and Jack, and we would still, our code would still run the same. String can be of any length. It is only limited to the memory available um, for individual computers. So let's say another example. I want to say string double and assign the value string example using double quote. When I do print, when I print as double, I would get the string output, a string example using double quote. I could do the same under using this time using single quote, like I saw earlier, and it would still run the same. Here's two different outputs because I have two different statements, uh, both for s underscore double, the first one using double quotes and then the second one using single quote. The output doesn't show any code, it just shows the string. Let's see more meaningful example. So let's say I want to declare first name equals John, and I want to store last name as Doe, which is still fine. So John and Doe are two string literals, and first name and last name are two string variables or are string data types. String doesn't have to be more than one character. Um, if we can just assign, let's say there was usually a middle name initial, so we can just say C, and then name of C would still be processed correctly. This is just a single character string. We can also do multi-line string. Multi-line strings can be denoted using triple quotes, where it can be triple single quotes or triple double quotes. A typical example would be a paragraph. So hi there. So let's learn about data types in Python. There are various data types in Python, and different types can do different things. I enclose this under triple double quote here and at the end. Um, and when I print paragraph, and see what we get. So we get all the text in the string that we input. Another concept I would like to provide is indexing in string. So indexing in string, when we say John, it actually is broken down into individual characters, and the first character in the string will always be indexed 0 and increment by 1 over each time. So J would be 0, O would be 1 index, H would be index 2, and N would be index 3. Indexing can also use negative values starting from the last integer or the end of the string. So this N would also be indexed as -1, and then H would also be -2, -3 for O, and -4 for J. Um, when we go over back to Python, and when we say, hold on, here. So when we remove this, when we say first name equals John, now we want to index starting from the first position. So for that, we would just say first name square bracket 0 for the first index. So if we want to see the output, we would just have to do print, wrap the print around this, and when we run, we get the first letter as output, which is the letter J. We can also um, reference different values with different index. So 0, 1, 2, 3. When we say first name 3, we would get the last character, which is the third index, because 0, 1, 2, 3. Sometimes when we work with the string, we don't know how long the string is. In case we are interested in finding the length of the string, we just have to do length of first name and run it. So we get length 4, which is how long John, the string character John is. String John. Another example would be when we say alphabet equals to A, and then when we similarly print length of alphabet, we would get 1. So in this case, it's just a single character string of length 1. Let's try that with negative index in Python. So let's go back to the first name example. First name is John. Let's bring first name back. And in this case, I want to print the last character. And let's assume that I don't know how long this string is. So in this case, if I want to access the last character, which is n, which happens to be 1 in this case, n in this case, when I run this, the last character index is -1. And when I print name of index -1, I still get n. Um, let's try another number, 4. So remember when I showed you this chart, -1, -2, -3, -4. So when I do -4 in this case, here I should get capital J. We have to keep in mind index error. Keep in mind about index error when we do string index that are out of range. So for example, as we saw, -4 is the first letter, and what do you think will happen when we do -5? Well, we get error, index error, because the string index is out of range. Similar error can be uh, output when we do positive indexing. Let's say first name index 5, which isn't there, and we still get the same index error output. Next thing I want to talk about is slicing operator with strings. So when we have a string similar to first name equals John, and we want to say I want to extract a portion of this string, um, we can do that using slicing. So for this, I want to go back to, um, uh, I want to exit out of this presentation mode and use console. Let's say in this example, s double is my string variable, and s double. So with slicing, I want to say I just want to extract index value 4 to 6. So what this means is I want to go from index value 4 to 6, 4 included, but 6 would not be included. So when I hit enter, it would give me ng. So 0, 1, 2, 3, 4, 5, and 6 is a space. So I would still only get 4 and 5, but not 6, which is a space. I could do something similar with a 0 in the beginning, and when I hit enter, I would get the first 6 letters of the string, which happens to be string in this case. Um, if I have 0 in the beginning, I could simply omit the 0, something like this, and still get the same output. I could also use negative indexing in slicing. So let's say I want to go from the first index to the last index of the list. And when I want to print this, so I'm skipping the first 0 index value, which is the capital S, and I'm printing everything else outside until the last, excluding the last item, right? So something similar to this. And if I don't include the -1, I would get the last item, which is the E. Slicing could be done without any values or empty. So in this case, it would print out the whole string. So you see how we can extract different portions of a single string using different index values using slicing technique. Let's go back to presentation mode because I want to show you um, I want to talk about um, mutability of a string basically. So let's bring back the S double string example. And let's say I want to start my sentence with a capital S instead of a small s. And if I'm trying to I would access this using string 0 or index 0. So something like print s double at index 0 would give me a capital or small s as an output. But let's say I want to change this to a capital S. So something like index value 0 equals capital S. But if I want to run this, it should give me an error saying string object does not support item assignment, which basically means it's immutable object type. So last thing I want to talk about when I'm at string is case handling in string. Uh, let's go back to this example of S double string example, which basically says string example using double quote. Let's say I want to print double quote string, but I want to print it in uppercase. So I simply do s double dot upper, call the upper function, run this, and I would get all the text in the uppercase. If I don't want all, but I want the first letter in upper, I could do something similar and say instead of upper, say title. And then I would get the first letters on capital case or uppercase. I can go back and get everything in lowercase if the string was stored in mixed case or uppercase, and I would get everything under um, small letters. Let's see another example. So let's go back to our name string variable, and let's go a little bit dynamic here. In this case, I want to say a mixed case of capital J, O, capital H, and N to spell out John. And if I say, if I run something code similar to this, um, now notice I have mixed letters and I have a string at the end. So if I run something like this, on the case of upper, I get all capital letters. In the case of title, I get capital J, but my capital H from my literal has been changed to lowercase now. If I go all lower, everything would be lower, just like in previous example. But if you notice, all these texts have that space at the end because our literal, when we assign, has this space after n. So when it printed out or when it basically manipulated that variable, each of the instance, we get that space at the end. So we can get rid of that space by simply saying print name dot right strip, and that would take care of that. Now we had spacebar on all three occasions. In this one, we don't have it. We can do right strip or left strip if there was a space on the left side. Like in this case, it would strip on both sides. Or we did L strip, so it only did on the left side. But if we only say strip instead of left or right strip, it would take care of both the strips, left and right. You see that? So strips are good way to work with strings. One interesting thing before I move on to next data type is that we saw upper, title, lower strips or left and right strips. Um, we can also mix and match them. So let's say I want to strip on both sides, but then this doesn't look right, so I want to use title case as well. So I can do something like this, and let's see what happens. Oops, a dot title, and oh, that took care of all the mixed letters and the space bars. So this is good example when you store or basically when user input their name. Let's say from a website, users are not restricted in a way. Yeah, let's say that they are free to use uppercase or lowercase or spacebar whenever they want, and it's up to us as a programmer to decide how to store them better for suitability issues or to reduce complications later on. So this is a good example on how you can do that. Although user in this case entered spacebar front and back, and then mixed and matched all the letters in upper and lower cases. When we store, we can store in proper format without space bars, using R strips, and then use title or lower uppercase um, to store the values appropriately as needed. Going back to our chart, we have already discussed numerical, integer decimal complex, and Boolean types. We have also just finished text data types. Now we are ready to jump into collections, which are basically lists or tuples, dictionaries, and sets. So we'll discuss about these four data types, and then wrap up for this video. Next thing I want to talk about is list data type. List is an ordered sequence of items separated by comma and is mutable data type, just like dynamically sized arrays in other programming languages. All the items in the list do not need to be of same type. It is one of the most used data type in Python and is very flexible. We use square brackets. So let's go by with an example. We use square brackets. So let's say I want to assign a variable named mylist. Use square brackets and items separated by commas. So let's say if I just want integers, I can just say 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go up to 10, and this would be my list. This is basically how I create a list of integers or values or numerical values. If I want to print my list and run this, I would get the list. Another example would be list of names. Let's say first names equals, and then I use the square brackets. Since I'm using names, that would be strings, so I need quotation, double quote or single, it doesn't matter. Let's say John, and then Tyler. That would be my two names. I can also print out this and see what happens. So in this case, I get John and Tyler. I can mix and match. It doesn't always have to be all integers or all characters. Um, I could mix and match and create a mixed list. So let's just say a mixed list equals square brackets. In this case, I want an integer, a floating point number, a string example. Let's say another floating point number. and I want to store same value with a quote, single quote. So here I'm using double quote and here I'm using single quote. Both are strings. I can also have a Boolean and non-data type. And similar to previous examples, I can still print my mixed list and get the list output. So in this case, it's a mixed list with integers, floating numbers, strings, another floating number, Boolean, and non-data types. I could do print type mixed list to get the type of this list, and it would say class list. A very common type of list that most of us use when we do programming, especially in different modules, to set colors. So let's say I want to define different colors or a list of colors that I want to use in my program. So I want to create a list of all the colors that I'm interested in. So in this case, I would be red, green, or blue. So RGB values. So list of RGBs. Um, I could still use to assign. I could use instead of text, I could assign numerical value to assign RGBs. So RGB equals 0, 0, 0. So these would be the RGB, red, blue, and green values that I want to assign. It's typically not done with square brackets, but I'm just giving you an example of how lists would work. Indexing and slicing in lists work very similar to that what we saw in string earlier. However, unlike a string, a list is mutable. So let's go back to our first example. Uh, our previous example, we said first name equals John and Tyler. That's a list of names. Um, I wanted to print names. If I print name, I would get John and Tyler. And then if I want to change one of the names, so let's say first name 0. Right now, index 0 has a value of John. So let's say I want to reassign that to some new name. So let's say Sarah. And then I need a print statement here. Print first name. And then after the change, I'm going to print again and show you how it works. So we started with John and Tyler on the list of names. Then here under index 0, which is the first value, I reassigned the value to be Sarah. And then when I print it again after reassignment, I get, instead of John and Tyler, I get Sarah and Tyler. So that's how we can work with index. And this shows the list is a mutable data type. So as we saw, list allows us to store a set of information in one place. That is why list is one of the most used data type in Python. It is therefore important to know how to properly handle list and be aware of powerful features. We'll be discussing list in more detail in a separate video. So for now, let's move on to another data type, tuple. Tuple is an ordered sequence of items, same as a list. However, tuples are immutable. An immutable list is called a tuple. Therefore, a tuple cannot have any changes in them once they are created, like we did here. This is because they support the same sequence operations as string. We use square brackets, or not a square bracket. We use the round brackets to create tuples in Python. Items in a tuple are separated by commas, just like in a list. So let's say here I want to do type of first name and get rid of this. So instead of square bracket, I change that to the round bracket or just bracket and print type first name. It would be a tuple. In the previous example, it was list. Now it's a tuple because of how we uh, how we use the brackets. We can do similar example to assign x and y coordinates. So let's say xy xy coordinate equals 9 comma 0. So that would be our x and y value. Um, this bracket around when we define tuple is not actually needed. It would still run fine. And when we do print xy coordinate, it would still print the tuple. If we print type of xy coordinate to find what is the data type, it would still correctly show tuple type. So the bottom line is the bracket around uh, the sequence of items in the tuple is not necessary, but we do it anyway just for readability purpose. Tuple like list can also be mixed tuples. Um, so in our previous example of list, we had integers and all sort of strings and booleans. We can do something similar with tuple. So let's say here I want to have mixed tuples, and this would, in like our previous example, it doesn't have bracket, but it would still syntactically be correct. And when we print this, it would print the whole tuple with brackets around it. When we do type of this tuple, it would correctly show tuple type, uh, data type. So when do we use tuples versus list? As we saw, list is mutable, tuples are immutable. So what that means is if we need to store values that we know we need to change later or can be changed during the course of when we run the code or anytime later, um, in that case, a list is more appropriate. But if we know that we want to protect data, then tuples are preferable. Let's say tuples are usually faster than list, and as they cannot be changed dynamically. Although we cannot modify tuples, we can still assign new values to a variable. So let's say in this case, we have to, this is of importance. So we are saying tuple is immutable. So once we define mixed tuple of these items, we can go back and say, hey, I want 10 instead of 100 here. But we can still define another statement. We can still do another statement of mixed tuple and say redefine everything with this. So we will still run fine. Um, but like we showed you in one of the earlier cases, the address of this new mixed tuple would not be same because the mixed tuple, as we defined earlier, tuples are immutable objects. So when we define tuple here, it would be stored in certain location. And when we define mixed tuple again, this mixed tuple doesn't replace this, but this is simply stored in a new location. And when we now use mixed tuple in our program, every time we use mixed tuple, we are referencing this location and not this location. So I hope that makes a little bit clear on what mutable objects and immutable objects are, and also when to use list versus when to use tuples would be more appropriate. With that, I think we can move on to a new data type, which is a dictionary data type. Dictionary is an unordered collection of data that stores values in a key value pair format. And to define dictionaries, we usually use curly brackets and create dictionary in Python. So let's say my dictionary equals, and we use curly brackets, we assign key value pair. So let's say A colon, and the value would be alpha. So instead of my dictionary, let's give it a more meaningful name, say phonetic dictionary. So for A would stand for alpha, and then we use comma to provide another item in the list, and then we use similar format. So B would be for Bravo, comma, and then C would be for Charlie. So here, these are my items, and every item you can see have a key and value pair. So A is key, alpha is the value for that key, B is the key, Bravo is the value for that key, C is the key, Charlie is the value for that key. Now, if I print type of this phonetic dictionary, it would correctly classify under dictionary data type. If I just want to type or print the dictionary, I just do print phonetic dictionary, and I would get the dictionary as output. Dictionaries can also contain different data types. Doesn't always have to be strings, like we saw in this case. So for example, I want to store a person's contact. So let's say contact 1. And I would create a dictionary using curly brackets. In contact, I would have first name, and the value would be John, comma, last name, and the value would be Doe. So this is the contact for John Doe or Mr. John Doe. Mr. John Doe also has a cell phone, and I would say store it in integer number for now. So that's his cell phone number, a comma, and then let's say he has A's and he is 45 years old. So in this case, it's a mixed dictionary. We're implementing contact in this example, which is a more practical example of how we could use a list. We store first name, last name, cell phone, and A's. These are the keys of bits of information that we are storing in this dictionary. And the values for those keys are John, Doe, the phone number, and how old he is. In this case, 45. So as you saw, we are storing string data type, integer data type. We could still do floats data types without issues. And if we were to print type contact, we would get data type of dictionary. So we got an error. So let's see. context. Oh, we're not using context, so we're using contact one. So that should take care of that. Alpha Bravo Charlie from the first example. Um, that was a class dictionary, and then here we're just typing dictionary we're not typing contact, and it's classifying as dictionary data type. Dictionaries, as you saw, are useful when we need to retrieve values when the key is known. So in this case, if we know the key, we can retrieve the person's name. Um, although um, that's in our example we didn't do that, but we can access values in dictionary. Um, Accessing values in dictionary is a little different as it uses keys rather than indexing that we saw earlier with the strings and lists. Um, Dictionaries are mutable. We can add new items or change the values of existing items using an assignment operator. So let's say we want to add another contact. We would just create another person under this. So or we want to add another information about this contact one, then it's easy. We just add comma and then add new value to the items. But we still have to maintain our key value pair format. Similar to a list, I would also create a separate video to discuss dictionary in more details. The next data type I want to talk about is set data type. A set is an unordered collection of unique items, so there should not be any duplicate items. We use curly brackets to create set in Python, just like dictionaries, but um, we're not using key value pairs, so we're just separating items by commas. Um, so so let's remove everything and say my or test set equals, and we use curly brackets 1, 2, 3, 4, 5, and then let's say 3, 2, 1. So I create this um, variable. Now if I want to see what type of variable is this, I could do print type of test set and run this, and it would give us a class of set or set data type. We could just do print test set, and interestingly we would only get values without duplicates. So if you notice here we have two instances of 1, two instances of value 2, two instances of value 3, and one of 4 and 5 each. But when the output, when it stores and when we are looking at the output of the stored set, what we get is unique values 1, 2, 3, 4, 5 without any duplications. So set can be used to perform mathematical set operations like union, intersections, symmetric differences, etc. Um, Set is also mutable. We can add or remove items from it. Similar to lists and dictionaries, I will also create a separate video to discuss set in more details. So if we go back to our data type chart, in our video today we have discussed numerical data types, and under numerical we discussed integer, decimal, complex. We also discussed Boolean. We also discussed text or string data type. And then under collections, we discussed lists, tuple, dictionaries, and sets. Then we also briefly discussed special data type none, which are also often used in Python programming. Now, all these are variables, and you might be wondering, how do we work with constants in Python? And before we wrap up this video, I would like to touch upon using constants in Python. So what is a constant? A constant is a type of variable whose value cannot be changed. And we saw earlier, all these data types that we discussed so far, we can, although they might be mutable and unmutable, the items can be changed or unchanged, but we can still reassign everything under new address with the same variable name. So there's nothing like a constant per se in Python, but we can still follow some standard conventions to emulate a semantic feeling of a constant. So what I'm saying is there's no equivalent for constants in Python like there would be in other programming languages. So to follow those standard conventions, what we do is we basically use all capital letters if we are to assign constants. So let's say pi would be a constant value or constant instead of a variable, and we can assign the value to its accurate decimal places. 9265359. Let's say let's assume this would be the value of pi, and we would store this value under the name pi, and we would capitalize this to indicate to ourselves and to other programmers that, hey, this is not a variable that would be changed later or should be changed later, but we are just using this notation to notify that this should be stored as a constant and not as a variable that would later be changed. Um, it's also recommended to not overly abbreviate names or use generic names when defining, especially defining constants, and that's purely for clarity purpose. Um, Usually, if you have a lot of constants to work with, it's better to create a module which basically is a new file containing variables or functions, etc. In this case, we will only have constants in the file stored, and then import that file into your main working file. So let's go back out, exit the presentation mode, and I can probably show you what I'm talking about. Come on. There we go. Exit presentation. Now, if I go to, I want to create a new Python file, and I want to say that tn constants. So that would be my file name. I still have the test file, and I want to move this constant out of the test file and define it here. So what I'm doing is I'll put all my constant variables and using this convention of capital letters to notify that, hey, this isn't actually a variable, but I'm using this as a constant in my program. So I would save this constant, go back to test, and now I would have to import this to this test file. So from constants import pi, right? So, and then once I import this, I would have flexibility of using it. I don't necessarily have to change the value. Um, so by using it, I could simply mean using under a print statement, right? So if I print pi in my test file, which is still the running file under when I run test, it would correctly give me the output that is stored in this constant value. So this is more conventional way of working with constants. If you have to work with a lot of constants, um, on the other hand, if you only have a handful of constants that to work with, you can simply um, just use the capital letter naming convention and stay within the same file and keep working similar to this. So that's it for this video, guys. Just to recap, we talked about um, different data types, storing data types using variables in Python, working with different types of variables, converting from one variable to another. Um, and we also talked about different attributes, identity types, and values of different variables. We also briefly talked about mutability and constants in Python with some working examples. Hope you liked the video. Please don't forget to like, share, subscribe, and comment below to show your full support. See you until next time. Thank you.